Let's invite live the leading expert of the Intellectual Transportation Lab for the Center of the Cognitive Transport Modulation of MIPT, Vitaliy Bezugliy.
Good afternoon, my name is Andrey. I'm an engineer at Huawei, and I will be the one who begins the presentation because this is our project, and then Vitaliy will take over. In this project, Huawei provided MIPT with equipment, Ascend servers with graphic cards to test our framework Mindspore. And our task here was to provide hardware and to fine-tune it and do the settings so that Vitaliy understands it as fast as possible and begins his scientific research and tests with our hardware. So over to Vitaliy, he will give you more details about the project and what he was doing with it. Good afternoon, my name is Vitaliy Bezugliy. I work at Intellectual Transport Laboratory and MIPT at Dmitriy's team. Dmitry has spoken here. I localize intellectual transport and robots, and we build semantic maps. Within the workshop, I would like to share our experience of our team and my own experience on development of models and training on models on computer vision with the help of Mindspore. During the workshop, we will discuss Mindspore installation. Oh, by the way, there is a QR code in the top right corner. If you scan it, you will find the presentation online, and you can watch the presentation online, or you can watch videos in the presentation. Maybe you will be, we will find it more comfortable watching videos on your device. So we'll discuss development of models, where to find them and what to do with them, and how to migrate to Mindspore from other frameworks. We'll look into training process of models and how to launch process, how to visualize the process. We will look into some features and properties of Mindspore, and we will compare performance of Mindspore and performance from other articles and open repositories. Installation. Mindspore is easy to install, but it's a little bit more difficult than just typing in install Mindspore. In order to install it, just open the website and open the installation tab. There's a panel here that offers you to choose the version that you want and the environment that you want, whether you want with Ascend, with GPU, with other CPUs, and you choose the operating system. There's a small example of how we do it. Just from this slide, you can tap on the link, you open the website of Mindspore, and you see this panel. Here you can choose the version. When you choose the version, oh, it switches off, okay. I can say a few words about choosing the version. There are two versions, 1.50 and 1.30. 1.50 was issued recently, and it has a lot of operators on it that were not available in 1.30, and you need them for training. For instance, we can say about our experience in order to train segmentation models. In 1.30, it was impossible. In 1.50, it is possible. It's available now. Sometimes there are some errors when you install a version 1.50. Maybe it's better to install 1.30 first or install it in another container. Right now, we will choose 1.30 for different platforms, hardware platforms. Mindspore has different versions. Different versions are available. Different types of installation through PIP, through source code. Right now, we're checking and making sure that we have GPU. And let's check the Python version. We have Python version 3.75. This is so we will choose the corresponding configuration, GPU 11 CUDA. And then we just copy this link and we paste it into the terminal. Here we have a pause deliberately because in the container Docker, let's mention this, you see that the command is quite long. It's for a reason, because by default it installs the version for CPU processor, and it might surprise you because it doesn't know what is Ascend. So in order to install a version that works exactly with CPU or with Ascend, you must follow this route, and the Docker will give you the name of the container that you will download in order to launch Mindspore. This container will have all the interdependencies except for Mindspore, because there are 3 versions of them for these platforms. Maybe in the future they will be united into one version, but right now, just in order to make it easier to update them, to upgrade them, and to develop them, there are 3 of them. So when using container Docker, you install it and then you repeat it there in container Docker. So we copy the command, we paste it into the terminal, and we run the process. It happens quite fast. Then we make sure that we install it right. On the official website, there's a special command to run internal Mindspore script in order to just verify that everything was right. Sometimes it helps verify that something went wrong before you launch your model, so it will save your time. So that's it. Mindspore has been installed. What's next? We have framework. What can we do with this framework? You can write your own scripts using educational pages on the website, or you can use documents, and they're very explanatory and very clear, straightforward. You can use ready-to-use models with high level of interfaces. Just a text download ResNet with this number of layers, and you will obtain ResNet with 1 code line. You can also use Mindspore Hub, which provides source codes of most popular models and scripts to train them from scratch to obtain the result that you can find maybe the best results. And final thing, you can transfer your models from PyTorch or TensorFlow. You can use the operator mapping table. They're very similar, but just in case you can compare. Or even you can use an automatic script that is called Mind Converter that helps automatically transfer your model, your script, from PyTorch or TensorFlow to Mindspore. Now let's consider, this is the next part of presentation. We have been saying just some general words. Now let's have a look at 3 specific models: WidersNet, SSD Lite MobileNet V2 FPN, and DeepLab V3+. And on the example of WidersNet 4010, we will search for a model on an official repository of Mindspore. We will install it and train it and visualize the process of training. On all 3 models, we'll see results of training process, and we'll compare performance with these processes and the quality of matrices. As I said, we'll compare them to third-party repositories. So, I thought it was video. So the structure of a typical repository of a model on Mindspore official website. We have an internal file that have brief description of the model and the dataset, then detailed instructions how to use the examples and how to do evaluation of models, and it shows results of how it will be run. There's a section called scripts where you can find scripts for training. You can launch them in most common scenarios. There's SRC folder. There you can see source code of the model and configuration file. And also TrainPy and EvalPy, they have all these modules together, and they launch the train process the way it's needed. Here we have a video. From this slide, we hit the link and we open the website. This is GT. GT is also GitHub, but very similar to GitHub. The same button, download. clone or download. Here we have two tabs, official and research. There are a lot of folders, but we will focus on official and research. In official, we have models that had been tested and they are ready to use, and they're considered to be work perfectly. And research is a folder that contains those models that work, but they haven't been tested enough yet to be in the folder official. So if you want to use a model, you open the folder official. Maybe your model is not there. If it's not there, then look into research and find it there. So in research folder, oftentimes you can find models where you can find scripts for Ascend, but without scripts for GPU. But difference in the scripts is not very significant, so you can use example of other models from Ascend with Ascend and GPU, and you can use other models. So let's continue. We open the tab, over here, and you have a spreadsheet here. You can see which models are available, what implementations are ready. But we are searching for WideResNet, and it's not here. But if we open research and then CV, then WideResNet will be found there, and we'll be able to download it and use it. It's in Chinese, but Google Chrome knows how to overcome it. Then we look at the scripts that we want to see. We need GPU train scripts. They're not here because it's obvious because there is no GPU prefix. So we're going to open my version of this repository. When I was working for Huawei, I was working on this, and I added those scripts and modifications so that we can train models on GPU. So we're opening my repositories. You can see that it's very open. It's really repositories, and it's in English here. All the scripts are available here. Then we copy the link, and with a regular git clone, we copy it here. And it's my branch. My branch where I was developing it, it hadn't been added to official repository yet. We clone it here. Oh, and by the way, there's one peculiarity here. Mindspore, an official repository, it has all the models together, and you can't download one separately. So you will have to clone the whole repository, about 200 gigabytes. If your internet connection is poor, then it will take quite long. So we have downloaded our repository. We have gotten those the parts that we were talking about, SRC, scripts, etc. Let's open them. Here we open script for GPU training. If you have a chance to look at the source code, then you use, and if you work not in the command line, then you can see what are the arguments, how you can run this script, and what it does to them later, so that you know it in advance, so that you run it right. If you don't have this chance, then you can run the script. So we go to scripts folder, or to Ultimate folder right away. ResNet scripts. And here we can run this script without any arguments, and it will give us a manual, will give some guidance how it should be run, and sometimes it even gives examples of some commands, but it's waiting for our response here. We'll see the dataset, the configure file, configure path. We see that the dataset is required, and we had not downloaded it. What are we to do? We open the website, open repository, and in README, we find description of the dataset and how to download it and what folders are needed. We download this and we look into the structure. Then we have an accelerated process of installation. It takes some time. Ultimately, I even decided not to do it because I have a dataset myself, and the internet connection was not very fast. We delete what we have just downloaded, and we're using what I had on the server. We go to scripts folder again, and we run it. We see what we need, and based on that, we just type in what we're going to use now. We configure file, test set, the name of the folder, experimental ID, and we can transfer ready checkpoint. We're going to transfer it now. We want to see how the model gets trained from scratch. We type in the command and we run it. It's called demonstration GPU, distributed training. Okay, we run it. Now, in the folder with scripts, we have a train parallel folder. Everything was copied for that model there. Here we have access to all files. And here we have a very long log file. First, there are parameters here, configuration parameters, and in the end, there is a log with lots of this model and with epochs numbers. So the model is getting trained. It works well. Now let's discuss specificity of launching distributed training on GPU and Ascend. In order to do distributed training, we're using NPE library. In order to run distributed train, we just need to use command gpe run. They are part of initial scripts. If you need to run scripts separately manually, then for distributed training, you need to use MPE run train, and you can see arguments. Since MPE is quite a diverse library repository, then everything is included here. We just need to run it. With Ascend, everything is a little bit more difficult. Mindspore has its own scripts and its own know-how and work between parallel processes. So far, there have been some limitations here in terms of distributed training here. The limitations are as follows. You need to run processes separately for every video panel. It works differently. It depends on, for every board it works differently, and then you put it into a separate folder. Also, in order to run training on Ascend, you need to transfer rank table to the script. Run table that describes our computing units in the virtual space of the server. It's nothing difficult. It looks a little bit scary, but since the majority of IP addresses and IDs are in virtual environment, you can just copy it from the manual on the website. And the only thing you need to type in here is server ID on the top of the screen. But if you are doing this training on a local server, or if you connect it to a server and you launch it there, then you just type in localhost and it's going to work. So now let's look into training visualization. Mindspore has a special tool for that. It's called Mind Inside. It's not a built-in exactly tool. There are some tools that are responsible for visualization of the results, and Mindspore itself has a system that logs the files, and you will need to address them there. And Mind Inside can be used for different things. It is also used for visualization of training process, for collecting hyperparameters, to see how hyperparameters are changing, for performance optimization. It helps optimize logs of GPU and Ascend profilers, and it shows very interesting diagrams and logs. You can also use it for hyperparameter optimization automatically, and also for debugging. Right now, let's discuss process visualization step, because we don't have much time. In order to launch very straightforward and simple mode, it's enough to use 2 lines of code. Install Mind Inside, pip install, also import self-recollector that is going to log it all, and then also type in model train. Then you run it. Here we have a small example how it works. Oh, we're going to have an example, but a little bit later. It's not the example yet. There it is. Was. Excuse me. It was a video. It was supposed to be a video here. Okay. So there was a video where I was showing in detail how training is going on here. We did the same steps that we're describing on the slide, and then we're going to see how it works. And Mindspore We have an integrated operator that helps record the files in a special format, loss, not only the projects, but everything we want to visualize. Then we just transfer the process as parameters, and it's going to visualize it. Okay. Apologies. Do I have a chance to run the video? Because there was supposed to be a video here. Okay. I remember approximately what was on the video, and online you will find a presentation and you will see the video there. On that video, we download the same repository, but this time on Ascend. And we begin the training process. In order to do that, we do all the steps that were indicated on the previous slide, and it's quite easy. And then we launch it. We run the training. So I had already explained it, so let's move on. Might Inside supports not just this out-of-the-box training, but also fine-tuning and fine setting. You can change parameters of summary collector. You can add special operators to computational graph to see what's in between, to see what the intermittent steps were. We're working with computer vision models, or you can write your own callback that will give you full control over what you receive, how the parameter works, how they're saved, and what interface is going to look like. It's very easy to write this callback. It has a few features that need to be redefined, and it's going to work nice and smooth. Here you can see a screenshot of what it looks like, and you can see here, you can look at the line 194, line 194. Here we initialize a summary save dir variable where we're going to save our logs. It is located in 3E inside here. In order to save logs for distributed learning, Made Inside also requires different devices to store logs in different folders. So we create summary save direct, and we then give the device number and get rank in order to know what kind of device it was. And in line number 308, I think, in model train, we write callbacks, and on line 195 we did it. Oh yes, it was a video. Yes, we have watched. We have seen how it's added on the example. Okay, so this is the video that I missed, but we don't have time for it anymore. I tried to explain it in words. Here we can see how Made Inside is being launched. Apologies. Yes, we have run the training. We can double check that it really works. This training is on Ascend. We're warned here that we're using mixed accuracy. This is why we use float 32 and float 16. Here are the warnings, the notifications. We open the directory where we have logs, and we call the Made Inside by with the help of this command. We run it, it runs great, and it even offers us to open it in a browser. We open it in a browser and see what's the result. Here's the interface, web version. We have different tabs for different devices. Here we can see training dashboard, and we can see graphs of scanners, computation graph, and distribution of parameters. So different visualization, different graphs with data processing during the training, different diagrams and curves with different functions for convenient analysis of training process. And we also have graph of training distribution of parameters, nice diagrams, and computational graph. It looks very nice here, and here it doesn't look nice. But actually, it's right, it is right, but doesn't look exciting. In order to see a more exciting version, we need to introduce another parameter there. We need to add it there, and we need to open another directory. It was switched off to speed up the model because it's quite costly to do this computation. In extended version, you can find the manual on how to switch it on. But here we can see just the result of what was done. And let's see the computational graph for WidersNet. It's a large-scale graph. It's very detailed. In detail, you can see what is going on and where. And during the debugging process, it's very important to see it. Here are some features and advantages of Mindspore. As Dmitry said, you can switch between different contexts. You can change the mode from static to dynamic and back. The one with interflow that helps accelerate and improve performance of the model, help to train better and to perform better. And the dynamic graph, where you can debug the model. It's easier to debug it there because it gives more detailed information and it's more dynamic, and it gives more information about errors, just like in PyTorch. And in order to switch this between the regimes, you just need to change one argument. Hybrid parallelization. The same diagram with data distribution in Mindspore. Mindspore provides parallelization of data, so we distribute not only the data, but we also can do parallelization of models, not just data, which sometimes is very convenient because models are very heavy and large and quite elaborate. So you can put it on one device. It's very hard to put it on one device. Or you can put it on one device, but device is not going to be used efficiently. And hybrid parallelization distributes layers of model in order to improve performance, in order to speed up the process, and in order to move video boards more efficiently. It's built into Mindspore, and it helps automatically choose parameters of distribution and avoid thinking about how to distribute it. You just switch it on and you use it. Next advantage is mixed precision. It's not a feature of Mindspore, but here it's as an automatic function. You can just transfer a few parameters to the class of models, and you will automatically have mixed precision. Mixed precision is a very useful tool that helps minimize the memory you use when training the model, and it accelerates the process. A larger batch, you use the video board capabilities more efficiently. Here is where is NAT. One table here has official repository, then the other one has third-party repository with a GPU. Here is WidersNet training and Mindspore. Mindspore training both on Ascent and GPU helps reach results non-inferior and even better. Here you can see the speed of Ascent and GPU. The numbers are a little bit incorrect because we did not use the best GPU. It was our in-house GPU. It was not the advanced one, and Ascend was used, one of the most advanced ones, but the correlation is going to be in favor of Ascend anyway. Performance of SSD, the same numbers. Here again, results from the article, 22% in average precision and 23% 0.3 for Ascend and NVIDIA. And you can see how much time was taken for one step of training, and full train, how much it results on Deep Lab and Cre+. If you make one step back, then WidersNet was just classification of images, 32 per 32 pixels, a very simple task. Here is a segmentation of objects in real-time mode. And next, we have a Deep Lab V3 Plus The previous one was detection, and this is segmentation of models in real-time mode, and both Ascend and GPU on Mindspore show non-inferior results. They're even better than training on Interflow. Here we have example of what it does. This is SSD Lite that detects objects in real-time mode. And here is an example of DeepLab V3+. Thank you very much for your attention. I don't think we have time to take your questions, unfortunately, but the slide has my email and email of my colleague from Huawei. And once again, QR code for this presentation. And if you scan this QR code, you will have access to the whole presentation. You will have an expanded video. It's going to be great if you have a look at this presentation and the video and ask your questions as long as you have them. Thank you for your attention.